The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter.
Using the James Webb Space Telescope, astronomers have spotted 6 massive galaxies, and they date back to within 500 and 700 million years after the Big Bang.
NASA's quest to explore the unknown depths of space is an endless journey that often leaves us spellbound. The burning question that lingers is, when will we be able to unlock the mysteries of exoplanets in the universe? Countless exoplanets are scattered throughout the cosmos, but we have yet to discover their true nature. That is, until now. The James Webb Space Telescope, a marvel of modern technology, has made a groundbreaking discovery that could change the course of space exploration. For the first time ever, carbon dioxide has been detected in the atmosphere of an exoplanet, giving us a glimpse into what may be a world akin to our own. The groundbreaking discovery of carbon dioxide in an exoplanet's atmosphere provides a fleeting resemblance to our own solar system and opens up a new era of research. Despite this tremendous achievement, the vast majority of exoplanets may remain hidden from our view. It is entirely possible that there are countless planets out there that we cannot see, and that many of them may be entirely inhospitable to life as we know it. So the question remains, are we alone in the universe? Or could there be other forms of life on planets that we have yet to discover? Let's find out. Webb's launch on Christmas Day of 2021 was the result of decades of tireless work by NASA scientists and engineers. The successful launch, coupled with the telescope's smooth deployment in the following months, culminated in the release of Webb's stunning first images in mid-July. The infrared telescope is capable of providing a clearer picture of our universe, with the potential to study even the most distant galaxies and offer us a glimpse into the past. Scientists who have already started using Webb have been amazed by the telescope's capabilities. According to Science, within days of the telescope coming online in late June 2022, researchers had already discovered thousands of new galaxies, some of which could be more than 150 million years older than the oldest galaxies identified by the Hubble telescope. Webb's ability to collect a vast amount of light from astronomical objects allows scientists to study the object's composition and movement in space. The telescope has already revealed the atmospheric composition of exoplanets, giving us an idea of their potential to support life. The JWST works at infrared wavelengths of light. These are rays that have a longer wavelength than the light we can see with our eyes. We generally perceive infrared radiation to be heat, which is why so-called thermal cameras are infrared in nature. The first images released were breathtaking. Giant celestial landscapes of dust and gas were revealed, as were the deepest reaches of the universe. There were huge interacting galaxies and dying stars in their final throes of life. But the images themselves, however mind-blowing, are just the tip of the iceberg. Behind them are mountains of data that are set to reshape our understanding of the universe. From the deepest realms of the cosmos all the way home to the celestial backyard of our solar system, there is not a single domain of the universe that the JWST cannot make a meaningful investigation. And Webb's discoveries have not gone unnoticed. The telescope was named Science Breakthrough of 2022 by the journal Science, and Jane Rigby, Webb's operations project scientist, was included in Nature's list of 10 people who helped shape science stories for 2022. Webb is a game changer in astronomy, and it has already achieved something that was once thought impossible: observing the most ancient galaxies known to mankind. In December of last year, scientists confirmed that Webb had spotted the 4 most distant galaxies ever seen, all of which are also the oldest, dating back to the dawn of the universe over 13 billion years ago. The telescope's near-infrared spectrograph helped to confirm their age by measuring their redshift, which indicates how much the universe has expanded since the galaxies emitted their light. Their redshift was the highest ever measured at 13.2. According to Brant Robertson, an astrophysicist at the University of California, Santa Cruz, and one of the researchers involved in the observations, these galaxies are well beyond what we could have imagined finding before JWST. Webb has opened up a whole new era of discovery, allowing us to observe the universe's most distant and ancient objects in unprecedented detail. The telescope's capabilities mean that we can now confirm that these galaxies are as old and distant as they appear, bringing us one step closer to understanding the origins of our universe. Now imagine being able to see worlds beyond our solar system, planets that orbit stars thousands of light years away. That's the promise of exoplanet exploration, and the JWST is at the forefront of this mission. With over 5,000 known exoplanets, scientists have been able to study them indirectly through the light of their host star. But direct imaging of these distant worlds has remained elusive until now. In September of last year, the JWST captured its first direct image of an exoplanet called HIP 65426b, located 100 times farther away from its star than Earth is from the Sun. This gas giant is a whopping 12 times the size of Jupiter, making it an ideal target for observation. Using advanced technology like coronagraphs, which block out the star's light, and two of the telescope's cameras with multiple filters, scientists were able to study the planet's atmosphere and composition directly. This breakthrough marks a new era in exoplanet research, one where we can finally see these far-off worlds with our own eyes. And with the JWST's powerful capabilities, there's no telling what other surprises we may uncover in the vast expanse of space. The TRAPPIST-1 star may not be as massive as our own Sun, but what makes it so intriguing is the planets that orbit around it. Located just 39 light-years from Earth, this system was first discovered in 2016 by the Transiting Planets and Planetesimal Small Telescope, TRAPPIST. The discovery was further validated by NASA's Spitzer Space Telescope, and now the JWST is following up with even more detailed observations. This star is different from our Sun, since it has a mass that is roughly a tenth of the Sun's and has a size similar to that of Jupiter. The planets that orbit the star, however, are what excite the exoplanet hunters. So what's so special about the TRAPPIST-1 planets? Well, for starters, they're rocky like Earth, and some of them may even be wetter. A recent study published in 2021 suggests that while these planets are rocky, they're less dense than the ones in our solar system. What's more, 4 of the 7 planets are located in the habitable zone of their star, meaning they're warm enough to support liquid water. That's pretty exciting, especially when you consider that all of these planets orbit closer to their star than Mercury does to the Sun. The impact of TRAPPIST-1 on temperatures is insignificant because it's much dimmer than our Sun, but it does have a significant impact on the environment of its planets. For example, TRAPPIST-1b, the closest planet, completes an orbit around its star every 1.9 days, which is very short. TRAPPIST-1h, the farthest planet, has a year that lasts about 19 days. Additionally, all of the planets are likely tidally locked, meaning that only one side always faces the star, similar to the Moon's relationship with Earth. Nevertheless, the variety of rocky planets in the TRAPPIST-1 system makes it the prime exoplanet target for the JWST. Despite being one of the most researched planetary systems, scientists believe that TRAPPIST-1 still has many mysteries to uncover. While the TRAPPIST-1 system is undoubtedly different from our own solar system, it's still fascinating to think about what these distant worlds might be like. Who knows what other secrets the JWST will uncover as it continues to observe this unique and fascinating system? Can JWST use its near-spec sensor to discover what gases are present in the atmospheres of these 7 rocky exoplanets? Methane, carbon dioxide, and oxygen are possible indicators of surface life and could provide information about the composition of a planet's atmosphere. According to NASA, the James Webb Space Telescope has found conclusive evidence of carbon dioxide in the atmosphere of an exoplanet outside our solar system. These groundbreaking discoveries could aid in the study of smaller planets and provide useful insights into their composition and formation. The James Webb Space Telescope's inaugural exoplanet campaign resulted in the discovery of a planet named WASP-39b. This exoplanet orbits a star located 700 light-years from Earth in the Virgo constellation. WASP-39b is a hot gas giant with a short orbital period of about 4 Earth days. It orbits extremely close to its parent star, at less than 1/20th of the distance between Earth and the Sun. The planet was first discovered in 2011, but it can only be seen during transits, which are small decreases in the star's brightness caused by the planet passing in front of it. Previous observations of WASP 39b were conducted by the Hubble Space Telescope and now retired Spitzer Space Telescope. These telescopes observed the planet using optical and infrared wavelengths respectively. WASP 39b is similar in mass to Saturn, but larger in size than Jupiter. Earlier investigations have revealed the presence of water vapor, sodium and potassium in its atmosphere. However, only with the Webb telescope was a signal of carbon dioxide detected. There has never been any evidence of carbon dioxide on an exoplanet, but experts believe that the detection of carbon dioxide on an exoplanet can aid in understanding the planet's formation and evolution. The discovery marks a significant advancement in characterizing the atmospheres of exoplanets. Carbon dioxide, being particularly sensitive to the conditions where a planet is formed, allows for measuring the total carbon and oxygen present in the atmosphere. These measurements can help determine the planet's formation distance, as well as how much gaseous and solid material it gathered during its migration to its current location. The discovery was made using Webb's NIRSPEC instrument, which is a highly sensitive spectrograph that splits incoming light into spectra that show how the object absorbs light. Instead of taking direct photographs of the exoplanet or its atmosphere, researchers compared measurements of the star's normal light with the light seen through the exoplanet's atmosphere when it passed in front of it. Experts suggest that Webb will be able to detect carbon dioxide in the atmospheres of many planets, including rocky ones similar to Earth that exist throughout the galaxy. The James Webb Space Telescope kicked off the year by adding another exoplanet to its list of discoveries. Last year, the telescope delivered breathtaking images of celestial objects, from the birthplaces and deaths of stars to the cosmic dance of galaxies. LHS 475b, the latest exoplanet to be confirmed, is almost as big as Earth, measuring up to 99% of our planet's diameter. Exoplanets are planets outside our solar system, and while some are floating freely in space, most of them orbit around other stars. The idea of these planets has been around for centuries, but the first actual discovery of an exoplanet didn't happen until the 1990s. It was in 1992 when two astronomers discovered a pulsar, the dense remnant of a dead star that emits pulsating beams of light while rapidly rotating. This pulsar was located 2,000 light-years away. 3 years later, two scientists found the first exoplanet orbiting the star 51 Pegasi, which was similar to the Sun. This exoplanet was a hot, gas-rich giant that orbited its star even closer than Mercury did to the Sun. NASA estimates that there is an average of one exoplanet for every star that can be seen at night, and over 5,000 exoplanets have been discovered so far. The closest exoplanet, Proxima Centauri b, circles around a red dwarf star about 4.25 light-years away, where 1 light-year is equivalent to roughly 9.46 trillion kilometers. Scientists have discovered exoplanets utilizing various techniques using both ground and space telescopes. And these planets come in a range of sizes, masses, compositions, planetary system configurations, and the number of stars they orbit. Some exoplanets are rocky like Venus or Earth, while others are gas-rich like Saturn or Jupiter. Additionally, exoplanets can possess densities similar to styrofoam or be coated in molten oceans of lava. These exoplanets may share similar components to planets in our solar system, but in different proportions, like having more water or carbon. By studying exoplanets, we can gather information about their formation, evolution, and the possibility of extraterrestrial life. Furthermore, we can better understand our solar system, as some exoplanets could not have formed as close to their parent star as they are now based on their compositions, implying that they must have migrated later, demonstrating that planets can travel far from their places of origin. What have scientists discovered about the newly confirmed exoplanet by the JWST? The planet, named LHS 475b, is a rocky world located in the Octans constellation relatively close to Earth, only 41 light-years away. NASA's Transiting Exoplanet Survey satellite, TESS, initially hinted at the planet's existence, but it was confirmed by the JWST. While the telescope indicates that the planet is similar in size to Earth, it is still unknown if it possesses an atmosphere. However, scientists have identified certain types of atmospheres that can be ruled out due to the sensitivity of the telescope. They speculate that an atmosphere made entirely of carbon dioxide may exist. The planet is also hotter than Earth by a few hundred degrees, and if clouds are detected in future studies, it could indicate that the planet is more akin to Venus, which is encircled by thick clouds all the time. With this groundbreaking discovery by the Webb telescope, scientists have only scratched the surface of what extraterrestrial atmospheres could look like. On the other hand, as the James Webb Space Telescope sets its sights on exoplanetary atmospheres rich in vaporized rock and crystals like corundum and perovskite, astronomers are hoping for overcast conditions. These atmospheres belong to gas giants called hot Jupiters, which orbit their stars at a close distance, causing temperatures as high as 3,600 degrees Fahrenheit to burn rocky elements, minerals, and metals into a vapor. Interestingly, many of these vaporized minerals are precious gems on Earth. On exoplanets, these minerals can even form clouds, a bizarre phenomenon not seen on Earth. Scientists have previously found such minerals in exoplanetary atmospheres, with titanium oxide having a distinctive signature in the atmosphere of hot Jupiter WASP 19b in 2017, as observed by astronomers using the Very Large Telescope, VLT, in Chile. 3 years later, the VLT discovered iron vapor on the hot Jupiter WASP 76b's day side. Hot Jupiters being tidally locked or always present the same face to their star causes their day sides to heat up tremendously, with WASP 76b's dayside temperature reaching a sweltering 4,000 degrees Fahrenheit. That's 2,200 degrees Celsius, compared to only 2,700 degrees Fahrenheit or 1,500 degrees Celsius on the planet's night side. Surprisingly, even at these high temperatures, iron can condense and precipitate out as a rain of molten metal. These minerals and substances have previously been found in exoplanetary atmospheres in a diffuse form, but studying them in a cloud form can provide valuable insight into the composition of these distant worlds. And get ready to be amazed in the coming months, as the James Webb Space Telescope will reveal a whole new world of discoveries about exoplanetary atmospheres. JWST's high-resolution vision will be able to study minerals like corundum and perovskite, which create gems on Earth, now directly distinguished as clouds and spectroscopically analysed. JWST's recent observation of WASP 96b's atmosphere featuring water clouds, previously thought to be absent, is just the beginning of what we can learn from the telescope. The JWST's agenda includes measuring the atmosphere's composition of the super-Earth 55 Cancri E, which is 8 times more massive than our planet, to determine whether it's hot enough to produce lava rain. Furthermore, the telescope will examine the TRAPPIST-1 system's 7 planets, scanning each one for an atmosphere. TRAPPIST-1e, the planet with the closest resemblance to Earth, will be the subject of special attention from astronomers. They're hoping to find evidence of habitability in its atmosphere, particularly through the study of its clouds. We all know how crucial clouds are in controlling temperature and determining Earth's climate, and it turns out they might play an essential role in the composition of exoplanetary atmospheres too. By understanding how clouds form on Earth and other planets in our solar system, we can learn about their evolution in more unusual environments. The more we learn from JWST's observations, the more we can discover about these distant worlds and the possibilities of life beyond our own. Besides this, the James Webb Space Telescope has made another fascinating discovery in the vast expanse of the universe. Meet VHS 1256b, a brown dwarf that's too big to be a planet but too small to be a star. This strange object gives off a dim reddish glow and has sandy silicate clouds, a feature that has never been observed in brown dwarfs before. Additionally, Webb's observation of the brown dwarf's atmosphere reveals the presence of chemicals such as water, methane, carbon dioxide, and potassium, among others, suggesting a turbulent atmosphere. The study of the brown dwarf's atmosphere, which is yet to be published in a journal, has revealed some intriguing findings. Normally, a calm atmosphere would have a predictable ratio of different chemicals, such as methane and carbon monoxide. However, in many exoplanet atmospheres, including VHS 1256b's, the ratio is skewed, indicating turbulent vertical mixing that dredges up carbon dioxide from deep down to mix with methane higher up in the atmosphere. These findings provide insights into the dynamics of exoplanet atmospheres and how they evolve over time. Now let's shift our focus from exoplanets to the Southern Ring Nebula, an object that scientists previously considered unremarkable. It was believed to be a dying star called a white dwarf that had expelled its outer layers, which glow brightly as it radiates waves of energy. However, the recent image captured by the James Webb Space Telescope revealed that there was more to the story. Using the near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, JWST found that the white dwarf was not invisible as previously thought, but was surrounded by a haze of cool gas. Scientists believe that this gas came from a third star hidden within the nebula, which was the source of the gas. The telescope also captured intriguing shells around the edges of the nebula, similar to those around WR140, which may have been caused by a third star located between the two known ones. This discovery is significant because it challenges scientists' previous understanding of the Southern Ring Nebula and highlights the power of the James Webb Space Telescope in unveiling the mysteries of our universe. With its advanced instruments and capabilities, JWST is poised to continue making groundbreaking discoveries and revolutionize our understanding of the cosmos. In conclusion, the James Webb Space Telescope is revolutionizing our understanding of exoplanets and the mysteries of space. With its advanced technology, it has allowed astronomers to make groundbreaking discoveries, such as the detection of carbon dioxide in exoplanet atmospheres and the identification of new types of objects in space. These findings have opened up new avenues for research and furthered our understanding of the universe. As the JWST continues to scan the skies, it is sure to uncover even more mysteries and surprises, further expanding our knowledge of the cosmos. We can't help but wonder what other groundbreaking discoveries Webb will make in the future. Let us know what you think in the comments section below. While you're still here, make sure to subscribe to our channel for more mind-blowing videos about space.